Hello everybody, I'm Untitled Chapter. Welcome back. Let us try to answer an item from the Bangladesh Math Olympiad, particularly from the junior section. N is a positive integer such that 2019 plus n factorial is a square number. Find all such values of n. Pause this video and give this a try. If you're done, let us dive in with the solution. Now the format of this competition is that for every item, a student must provide a proof to the solution. So we're not just asking to find the values of n, we must also prove that those are the only values. So in Olympiad math fashion, let's do this starting with our claim. So to start with the solution, we start with the claim. We claim that the only possible value of n is n equals 3. And we must show that n equals 3 is correct. So everything will be done in Olympiad fashion, so which gives 2019 plus 3 factorial, which is equal to 2025. And this is equal to 45 squared. So although the next few parts might seem trivial, now what's very difficult in solving an Olympiad problem is the motivation to do it. But hopefully this video will provide some insight and some inspiration for you to do in a future math Olympiad that you may participate in. So one of the very common things to do in this item is to check modulo congruences, because particularly in this case, since we're dealing with 2019 plus n factorial being a square number, we can use modulo 4, which is a very common thing to do in math Olympiads. So let's start with the proof. So suppose n is greater than 3, then n factorial is obviously divisible by 4. That should be obvious enough. Like if n is greater than 3, for example, like 5, since 5 will always have a factor of 4, because 5 factorial is 5 times 4 times 3 times 2 times 1, it will obviously be divisible by 4. So that part should be obvious enough. However, we should check mod 4. Now 2019 plus n factorial, since n factorial is already divisible by 4, that's just 0. So we just get 2019, which is congruent to 3 modulo 4. And this is true for all n greater than 3. Now this this symbol here, an inverted capital A, is read as for all in mathematical proofs. So this, which means that it'll hold true for everything that you put after. So in this case, this statement, 2019 plus n factorial is congruent to 3 modulo 4, it's true for all cases stated after this symbol, so for all n greater than 3. Now, the thing is that some number that is congruent to 3 modulo 4 cannot be a perfect square, and we show why. We can conclude that no n greater than 3 works. Under modulo 4, obviously we have 4 possible cases. Some number is 0 modulo 4, some number is 1 modulo 4, 2 modulo 4, or 3 modulo 4. So, some positive integer, sorry. So some positive integer is 0, 1, 2, or 3 modulo 4. Now squaring all of them would give us x squared is 0 modulo 4, since 0 squared is just 0. Now if x is 1 mod 4, then x squared will simply be 1 squared mod 4, which is just 1 mod 4. Now if x is 2 mod 4, then x squared should be congruent to 4 modulo 4. Now since 4 is congruent to 0 under modulo 4, so we just have 0 here. Now if x is congruent to 3 modulo 4, then x squared will be congruent to 9 modulo 4. Now 9 is congruent to 1 modulo 4, so we have 1 here. So in all cases for x squared can only have 2 residues under modulo 4. It can only be 0 and 1. And unfortunately, or fortunately for this item at the least, no perfect squares are congruent to 3 modulo 4. So going back, 2019 plus n factorial is congruent to 3 modulo 4 for all n greater than 3. If that's the case, then 2019 plus n factorial is never a perfect square, since it is always congruent to 3 modulo 4 when n is greater than 3. Therefore, it suffices for us to check positive integers n less than or equal to 3. So those are just 3 cases. We just need to check n equals 1, n equals 2, and n equals 3. So we check each case from there. So now if n equals 1, this will be 2020, well, which is not a perfect square. If n equals 2, this will give us 2021, which is also not a perfect square. If we try n equals 3, this will give us 2025, which is a perfect square as shown in the earlier part of the video. So we check for all cases. We check for cases for n greater than 3, which we found out that is impossible. And it suffices for us to check positive integers n less than or equal to 3. And we've successfully done it. So we've successfully covered all positive integers n. And from this proof, we can finally conclude that the only possible value for n is n equals 3. Now usually proof writers would put a box here to indicate the end of the proof, or write QED. So this is just a just a little formal session on how to write proofs in Math Olympiads. So hopefully you guys learned something new from the video. And by the way, what is the final answer to this item? Well, the final answer to this item in particular, if you want to get full marks, is the entire solution. So starting from the claim up to the end, your solution would be the final answer.